Welcome to another episode of Executive Sessions, where we discuss trends, developments, and other topics surrounding the industrial manufacturing sector. I'm your host, Clayton Gullett, and I'm so excited you've joined us today. Technology and operations go together like peas and carrots, as Forrest would say. But today, these two are more entwined than ever. From solving problems on the shop floor to understanding how to engineer solutions. For operations, these are arguably more important due to a complex and changing world. So today, we'll discuss how to keep up in the fast-paced environment of industrial manufacturing, which is why I've asked these two gentlemen to be here with me today. On my left is Sir Scot Duncan of the Duncan clan, the Chief Operating Officer and co-founder of MiddleGround Capital. Welcome back, Scott.
Oh, thank you. It's good to be here.
Yeah, it's quite the title, too.
It has been a while, actually.
It has.
Yeah.
The pilot episode was the last
That's right.
Yeah.
First songs. Right.
And then we have Sir Stanley Stanford, the Managing Director and Head of Operations at MiddleGround Capital. Welcome to the show, man.
Happy to be here.
I'm happy that both of you are here.
First time caller.
Oh, yeah. First time caller. What makes you call in today, Mr. Stanford?
I think I was voluntold.
Oh, yeah.
I'm happy to be here.
Oh, okay. Well, that's good. I'm glad you were voluntold. Well, let's dive in really quick. Scott, you've got a background in engineering with technology, technical solutions, and operations. How has your experience shaped how you've solved problems you've encountered?
Well, first I would say the normal thing that I think people do when there are problems on the shop floor, Stan, I'm sure you've seen this, the first thing that most people do if they really want to go solve the problem is to go and see what happened. And what I find a lot in my background is that they go and find out what happens. If they find that some operator made a mistake, and then that's it. That's the end of their investigation. And they say, okay, well, John put this part in wrong, or John didn't, handle this equipment right. So it's John's fault. So let's retrain John, and let's have him sign that he was retrained, and then that's about it. And it's kind of like a, the Toyota has the 5 whys of how to solve a problem. It's more like the 5 whos, or the couple whos. And then they get to the point and say, okay, well, this operator made a mistake. But, I think there are ways to fix that with technology. And Toyota has a concept of the poka-yoke, which is like error proofing. It's like a way to make sure that you can't put something on wrong, or you can't do something wrong. And I think that's where a lot of, if you are kind of really thinking about engineering and thinking about technology, that's one of the ways that it can help solve problems is to put in place ways that you physically can't make that problem again. And so, and it can be really simple. If there's a part that needs to be installed to another part, and there's a way to make a little jig or something, or a holder for those two parts, and it actually physically can't go wrong when you put it down in place, that's a simple solution. It's a simple solution of technology. I call that technology, but it's engineering a simple solution so that people can't make mistakes. If you just leave it at, well, that person made a mistake, it's going to happen again. People are people. People make mistakes. And so I think the use of technology in, kind of solving those problems or preventing them is really kind of the next step in what people need to do. And then actually there's even a further next step. And, when you work with designers for parts and things like that, you can actually design it into the part so that it's impossible to do it wrong. And that's the best thing. That's the best thing for the operator. It's the best thing for the parts, the best thing. But to get to that solution, you have to push designers. You have to push people that are making the parts. You have to push the engineers to make the jig, to do it, because people don't naturally do that. It's more work for people to do that. But that's one of the simple ways that I think technology can be used to stop problems, because, really at the end of the day, the best thing to do is make it almost impossible to make a problem. You know what I mean?
Absolutely.
And I think just to piggyback off of that, when you look at, as Scott mentioned, going to the shop floor and truly doing problem solving, 97% of the time it's not a people issue, it's a process issue. So really working to get to the root cause of what's causing the process issue. And then you're looking both short-term and long-term. So you've got a short-term solution you can put in place, which may be some type of manual poka-yoke, but at some point that's going to be bypassed on accident, or somebody's going to forget to do it. So really putting the problem to bed, so to speak, of, putting a long-term solution in place that eliminates the ability to make that mistake. And I think design for manufacturing are some long-term opportunities. But I will say two things required to do good problem solvings at the Gemba are common sense, and you got to be able to listen and think.
That's actually a good point. And that actually jumps into my next question for you, Stan. And that's more of, you touched a little bit on like how somebody kind of navigates those problems. But as a managing director, those obstacles that you face in production, how do you find like technological solutions to those? Like, I know you've had an extensive career that's been very successful for a long time. That's why you're here. But do you have any like examples or anything like where you've gone and you've like worked through to solve those types of problems?
I think, at a high level, you're looking at, KPIs at the plant level or the division level or at the corporate level, understanding kind of where your issues are. But at the end of the day, you're trying to put together, if you've got quality issues out in the shop, you're trying to put together a Pareto chart that shows you what the top quality issues are. And then you're going to tackle those quality issues kind of in that particular order. And when you look at that, so for example, in my past, we've had an issue where we were missing O-rings in certain particular parts, and missing those O-rings could cause some uncommanded movement out in the field. So from a safety standpoint, that was very, very critical for us. So, we put some short-term countermeasures in, as I mentioned before, to kind of stop the bleeding, so to speak. And then, we use vision systems to inspect the part that would say yes or no, the O-ring is in place before it would actually allow a tool to work. So really took that out of the operator's hands of potentially missing that, because if an operator's in the middle of the process and he goes on break, he comes back and starts the process again, he don't always know, or she doesn't always know where they stopped at. So I think it's critical. Again, you can't play whack-a-mole with a lot of this stuff. You've got to put actual good processes in place. And that's something that our automation team here is, actively working on, is, from a visual standpoint, vision systems and things like that to really help out in the shop and eliminate those type of potential issues.
I got you. Well, actually, okay, well, then I'll open this up to both of you, because I've heard it's kind of an employee who needs training or needs to take the accountability, but also in that same junction, like ironing out processes and understanding where those issues are. What is the biggest challenges that production faces today, and how do you go about tracking those down?
I guess from my perspective, I think the same problems you have in production today are the same problems you had 20 years ago, in a lot of aspects. But I'd say the biggest things that we're running into today are, the ability to find good people to work in the facilities. And, it's a very competitive environment, unfortunately, or fortunately, however you want to look at it. And then I think you look at the average tenure for an employee over the last 20 years. I can remember 10 years ago in some of the facilities that I ran, you had an average tenure of 25, 26 years. And now I think that's down to closer to 10 to 12. So that's a big problem. You've got a lot of experience that is retiring or walking out the door that is very, very hard to replace. And being able to get those people up to speed, I think is probably one of the biggest issues that we face, and probably will face for the next 5 to 10 years as people retire. And, we've got that in our portfolio today. We've got our automation team dispatched to a location that are having some trouble with some PLC-related issues, robots and conveyors. And just the experience at the portfolio level, it's not their fault. They just don't have the experience. But luckily, we've got that experience in-house that we can disperse that. And the big thing that they do when they're there is, try to understand and give them some of the basic tools of problem solving that they would go through and kind of bring them along. So I think, human capital and then just the knowledge that you've got walking out the door, personally for me, is probably one of my biggest concerns.
Yeah, I agree completely. I think that, we've talked about this, I think, in the past, but there's just people, don't flock to manufacturing jobs the way they used to. It used to be seen as a high-paying, stable job, and now it's not. And so, with the lack of experience, I think it makes it even more important, the things that we've talked about, making good processes, making good standards, making it so that, you're not able to, to make mistakes as much as possible. The least amount of, sort of onus that you put on the operator, the better, because because of the lack of experience that we have in our factories right now. Now, I also think about it from a managing standpoint, because Stan and I both managed operations. There's challenges in managing operations. A lot of those are human capital related too, because of people and, just making sure that they are where they need to be and doing the right thing. But I think about how, we both talked about, when we talked about before about a problem, the first thing we talked about was going to the shop floor and figuring it out. Well, that's just kind of ingrained in us. It's not ingrained in a lot of people in a lot of companies. So I always say, if you put the right people in the right place, looking at the right thing, they're going to fix it. But it's not always natural that you have a problem, whether that be a bottleneck, like equipment's not working right, or you have some sort of a quality issue or potential quality issue. It's not always the case that, management's going to be there and engineering is going to be there and the safety department's going to be there. It's not always the case. And it used to be the case. That's how I grew up, is that everybody would go look at the problems and kind of, cross-functional fix it. So I think part of, the challenge is getting people to actually go out there and figure out what their part of the problem is so that they can fix it. And, a lot of times we put in safety walks, we put in Gemba walks or whatever, where people walk around and look at some of the issues on the shop floor. And it's amazing. You do something simple as that. You get an engineer who's used to being, in his office doing his engineering work, and I'm sure he or she has a lot of work to do, but you get him out there on the shop floor and you have him talk to the operator who's experiencing the problem. Next thing you know, there's a solution because it's smart people putting the right people in the right place.
Okay, that actually is a really good point. So my dad worked at a refinery for 47 years. And so when COVID hit, they had massive layoffs, and so a lot of his generation and stuff was like they were thanked and then they were asked to go. So he, like everybody, was forced into retirement and things of that nature. So one of the things that you all brought up was that experience gap, going from 20 to 30 years to people to like 10 or 12 years. That's a major impact, I'm assuming, to production in general, because that was something that my dad and I had talked about. Was you have a loss of safety experience. You have a loss of in-the-field training. You have a loss of just on-the-spot reaction every time. So how do you go through and bridge that gap? Like, what is the process? What does that look like?
I think I'll give a really good example. So the company I used to work for, one of the facilities I was responsible for, we had a lot of screw machines. And we had an operator there that could literally listen to the sound of the machine, and he could tell you how it was performing. He could tell you when it needed a tool change. Like, wow. That's not something that somebody that was 12 years experience is even going to be able to do. So I think being able to, and Scott talked about it, like putting a lot of the standards in place and the checks in place. And he referenced, a safety walk, but you can put that in place from a preventative maintenance standpoint. So I think really rolling out systems and processes, and it doesn't have to be, something that you pay $30,000 to a vendor for. It could be something as simple as a check sheet that, you use. And I think that's the key word, use. And it requires, a plant manager to hold accountability at the shop floor level that we're going to use this and show the importance of it. So I think those are just some of the things that I've seen in my career, but just somebody that can listen to the decibel level of a machine and be able to tell you what it's doing and knows exactly what to adjust. That's just
so wild, man.
I don't even know that you can document that. That's just,
yeah.
And the good and bad thing, you're working on really, really old equipment in some cases.
Right.
But you've got great new technology out there that you can upgrade to, but the old equipment is still running and running great. But it's just a different breed of individual that grew up working those machines and being able to do it.
I think it's a good use of technology. I mean, we're talking about technology, but that, supplementing an operator's experience with some easy technological things. I mean, a lot of people think about engineering and technology and they picture a piece of equipment as big as this room and costs $500,000. That's not what we're talking about.
Right.
We're talking about little simple things like, Stan mentioned cameras, and that's one of the things I was going to talk about today too, because vision systems and camera systems are so much better than they've ever been. They can detect like minute cracks, dents and things, and they can be mounted over top of a moving conveyor and do that. We had that experience at one of the companies I worked at before where people were in a position where they were trying to detect cracks in bolts and screws, and it was almost impossible for them to do it. Some of the more experienced operators found more than others, but still, and there were, people that were there, and that was their whole job. They just sat there at the conveyor and looked for cracks in screws and bolts and nuts, and that's hard to do. I couldn't tell the difference. But you put in a vision system, and the next thing you know, they're finding those issues, and they're not going further down. You have to stop the problems as early as you can. And simple technology. I mean, Stan just talked about hearing the equipment and the vibration. It was probably some vibration because something got out of whack, because something was wearing different. But there's simple technological things that can find that too. You know what I mean? There's vibration systems, and there's even decibel readings and stuff like that. Some of that stuff is not that expensive, and you can still use it on old equipment. And it just kind of helps operators find this kind of stuff.
And I think one of the things Scott kind of mentioned, was, really understanding the standard work, because all we're trying to do is get a good, repeatable process. So I think with the technology today, and it's something that I've seen in my past as well, is, being able to put together, work instructions that are like on a big screen TV in front of the operator. So as they're going through their process, they can easily look up and see. You can show a video, you can show, hey, you place this here. And I think that's some of the ways that we can help bridge the gap between, kind of the people that are retiring and moving out versus the people that are moving in. And I think utilizing technology to maybe recruit as well, because as Scott said, like, not a lot of people want to go into manufacturing jobs. Like, both of my parents work manufacturing jobs, so I always thought I had a great childhood and did have a great childhood, and I was like, manufacturing provided for them, it can provide for me. So that's kind of where my love for manufacturing came from. So I think, how do we inspire the next generation to want to come into and do manufacturing?
Absolutely. Well, okay, Scott, actually, I want to add on to a point that you said, because one of the questions I was going to ask you was managing quality of a product without sacrificing quality and raising the price of the product and passing that on to the customer. You've talked about simple engineering solutions and things of that nature. Do you think that the technology that is coming in can kind of sub out that loss of experience as a result?
Yeah, I absolutely think that. I think that's one of the best uses. Obviously, I think that we would say that, you use technology first and foremost where you need to on things that are not safe. That's the last thing we want is for operators to be around in a process that's not safe or, whatever. And that's a good use of technology. And that sometimes can cost money, but it's a good use of money. Simple checks that are in place, where technology can be used to find problems before they become problems, like at the source of the equipment. You don't want anything that is a quality problem to leave that particular process. And so if you can help the operator with vision systems or with other checks, and they also have checks that they need to do. I mean, they will kind of walk away from the equipment and do physical checks like that. It's got to be kept there and really shouldn't have any impact necessarily on the quantity that are being produced as long as everything's operating correctly. That's the point of the frequent checks. I mean, Stan talked about, the screw machine company, and I think I know which one he's talking about, and I was there too. A lot of what they would do, the operators had their checks that they had to make. They would take a component out and go back while the machine is running and do all the checks that they do. But in the meantime, the machine is still running and it's creating parts. They're just held for a while.
Yep.
And then when the operator says, okay, well, that part meets standards, then he releases all those parts. And it was really easy. They just dumped into a different bin. And then he took that bin out, he or she, and said, okay, I did my quality check. That one's good. So I'm releasing these. And they got released for the rest of the process. But if there was a problem, then at least those were quarantined, and it was quarantined right at that location. So, I mean, I think it's got to be built in. It's got to be simple, something that is easy for the operator to do, and it's got to be something that is right at the process. If you wait to the very end to inspect for quality, you're going to be in a problem, and that's where people start finding lots of issues. Then the next thing you know, you got hundreds or thousands of parts in the system that are suspect. that's when there's a problem. If you can catch it at the source, that's the best thing to do for quality and for quantity.
Yeah, and I think Scott mentioned safety first, of course, but then the next thing is quality. And how do we eliminate any quality issues that impede the ability for an operator to build the product, build it well, and ultimately we don't want that. To Scott's point, if you're waiting till the end of it, some of that's going to get out to the customer at some point. So, using technology through engineering, so design for manufacturing. Scott mentioned that during his the first question. Using that, I don't think we did a good job of that industrial over the last 20 years, but I think that's something that some of them do a great job of today, but not everybody. But really designing for manufacturing, manufacturability, built-in quality with ownership, that's something that Scott had mentioned as well. But, being able to do that and do it well with technology, and, something that took, 4 or 5 machines 20 years ago, you can buy a machine today that will do all of it and do it quicker. So I think, as we progress with, concerns on, being able to staff positions effectively, we've got to embrace the technology, embrace the new machinery, and it changes every year. And, it does a couple of things. It keeps us very competitive. I think it can help us, recruit people, and, people at the end of the day managing machines like that, they're a little bit more complex. I mean, it's a higher caliber job that would pay more. So I think, embracing technology again to recruit and make manufacturing look good again.
Mm-hmm.
Well, it sounds like then technology might be able to maybe inspire the next generation to come in, maybe more complexity to the job, and maybe, I guess, in a way, making it more engaging, because like you were saying, I mean, going through and just like taking apart and like looking at it by hand and being like, yeah, that goes. Doing that day in, day out, that become very monotonous after a while.
Oh, yeah.
Okay, well, so here's a question for both of you. When you walk into a factory, obviously you have a wealth of knowledge about new technology that's entering the market. How do you go through and actually determine we need to start here? This is where we need to implement technology, versus whether that's safety, production, whether that's a new computer system that helps manage part ordering or any of that nature.
Again, I mentioned earlier, like, I'm a very common sense type guy, but, I look at safety first. So is anywhere that there's a safety related issue where somebody could be hurt, I think that's absolutely priority number one. Then from a quality standpoint, if it can impact, the customer in any way, that's a great place to start. And then anything, that's impacting delivery, like from a bottleneck standpoint. So safety, quality, and delivery are kind of my go-tos of where I think we should start. And I think, Scott going into a plant, me going into a plant, we've got a fresh set of eyes and have a fresh set of ideas. But I think really understanding the safety, quality, and delivery aspect really allows you to at least, narrow down the focus of what you really want to work on. Because, you've got plant managers out there that are working 12 hours a day, and they're on the shop floor 12 hours a day, and they don't get anything accomplished. And I think I think John Stewart talked one time, we were talking about KPIs, key performance indicators, and they're called key for a reason. So if you've got a quality issue, don't be tracking these 10 other things. Knock out the quality issue. If you've got a productivity issue, track productivity, don't track quality. So I think being very, very pointed and very surgical on how you're looking at the processes, because it's not one size fits all.
Yeah, I agree. And one of the things that we haven't really talked about, I agree completely with what Stan's saying, safety, quality, productivity. One of the things that we really haven't talked about using technology much, really, is just general shop floor management. I started my career at Toyota. Toyota had andon boards everywhere. They had noises and sounds everywhere. It was hard to be on the shop floor and not know when there was a problem. But a lot of factories are not like that. A lot of places that we acquire and go into, you could kind of walk through the shop and think, okay, well, things are going pretty good. And then at the end of the day, it's not. And that's one of the things that we like to highlight too in our shops, is that if you have the ability to see how things are going in real time, it can really make a difference for the operation of that facility. Because what will happen is there'll be one problem, one place, and because everything's interconnected, the whole shop suffers because of one problem, that really you don't find out until you get a report at the end of the shift. And that's not right, and that's not a good use of everybody's time. We can put in systems, so that they can kind of manage the shop. They can see how things are going on a real-time basis. And that matters because shop floor is so dynamic. You can go out there and get the shift started at 6 o'clock in the morning. Looks like everything's going well. Go get a coffee, and next thing you know, everything is, not going the right way because of one problem with one piece of equipment, one operator and one piece of equipment or one tool. But if you have a system in place that you get notified of that, then you can get the right resources there to help it and fix it and that not be a problem all day. So technology can be used in that way too, to manage the whole shop. And that's something that when we put in place, we never regret doing that.
Yeah, and I think, there's some manual systems we typically start out with, like an escalation procedure. So if you've got a critical process that's down for more than 10 minutes, maybe, the manager gets notified. If it's down more than 15 minutes, the plant manager gets notified. And you would think that would be in place at a lot of facilities, but it's not necessarily. And then, we've seen some good output with tracking related items at the machine that actually will email somebody when there's an issue. So to Scott's point, the more data we can get in the hands of, say, a plant manager, the quicker they can react. And one point I want to make, Scott made a great point of, you can be out working on problem A that popped up that's killing you, but you got these 3 other problems that probably are a bigger priority and a bigger focus. You just don't know about them yet. Mm-hmm. And it's just how do you prioritize that and be able to get that information to somebody quickly is kind of what we're looking to eliminate.
Just working all the gremlins out, basically, right? All right. Well, we're almost out of time, so I've got one more question for both of you. How can business owners stay competitive in the production world while trying to incorporate better technologies? And how do they avoid breaking the bank to make that happen?
I think we've talked about a lot of those things already. I mean, to summarize, I think a lot of what we would say is, technological solutions are simple. And we're not talking about big pieces of complex equipment because those end up not operating the way that you want. Generally, you got to have more maintenance people. You got to have a lot of engineering focus on those. The simpler, the better when it comes to implementing, technological solutions for things. And that's, that's assuming that you're going to fix the problems that you can on the shop floor with those technological solutions. You're going to have things that if there is a problem, stop the line immediately, get some support over there to get it fixed before there's a whole shop full of problems. But I think ultimately you still have to kind of, as much as you can, you push it back to design for manufacturing, for quality reasons, for safety reasons, for production reasons, if that is within your wheelhouse to do. If you have the ability to fix the potential problems with the way that parts go together, that's the best thing by far. If you can't do that, then you can put in simple technological, fixes here and there, cameras, monitoring systems that are cheap and simple. And then if that can't work, then you go more complex. But you have, with technology, I think you start simple and go more complex only as a last resort when you have to. And that, that is the best and, best solutions and generally those that have the best outcomes, but also the cheapest. It's kind of like a win-win.
And I think, if I think back to my past, a lot of the successes I've had is, again, I'm going to go back to, listening a lot and having a lot of common sense and just delivering a quality product on time. And what does it take to deliver a quality product on time? To Scott's point, you don't have to spend $5 million. You can be very selective on what you're implementing, why you're implementing it, and how you're implementing it. And I think looking at it from a safety, quality, and ultimately delivery standpoint eventually gives you a competitive advantage. I've seen businesses, actively win business and grow and not necessarily be the cheapest because they're great to work with, they've got a great solution, and they're very reliable and a great partner. So I think just, quality product on time. That's simple.
I gotcha. Well, I guess if you boil it down, the simplest solution is the best place to start. And if you have to make major changes, be surgical about it and don't do a broad sweep. Mm-hmm. Well, We're out of time, but thank you all for joining us for another episode of Executive Sessions. And make sure to subscribe to our YouTube channel and hit that notification bell so you never miss an episode. A big thanks to Sir Scot Duncan and Sir Stanley Stanford for taking time out of their busy schedules to be here with us today. Also want to give a huge shout out to Noah Day, Clark Freeman, Andrew Umvericht, and John Stewart II for making this come to life. You can't see them, but they're right behind the camera, and they make it all happen. So thank you guys very much. But that'll do it here for us today. Join us next time when we discuss more about trends, developments, and other exciting news surrounding the industrial manufacturing world. We'll see you then.